So let's continue with another go on the next exercise, problem 13. So G3 vanishes, G2, that means our function here is 4 set to the third minus 4n squared set. So the roots are, we'll just write them here. E1 is minus n, E2 is 0, and E3 is n. All right. Show that omega 1 is I times omega 2. Oops. I just lost concentration there. That's easy because it's given by the integrals here. So we can just take the integral from E1 to infinity and E minus infinity and E2 to infinity, and then this one is imaginary, this one is real, but apart from that, they are identical because the function is symmetric around naught. So that's really easy. Now, if we look at problem 12, I'll just write the formula. I'd like to make this formula from 12. Now, these parts within the integral signs are equal. So here we get a real positive result, and here we get the same result, but with a minus, and then we multiply by I. So half omega 1 is minus I times a half omega 2. And multiply by I. That's hopefully what we had to show. They write it the other way around. Never mind. So the lattice is Gaussian integer, lattice expanded by a factor W omega 2. Now, if we Z travels along a straight line from omega 1 to omega 1 half r plus omega 2, So omega 1 is the imaginary part here. And then we go to omega 1 plus omega 2. I really don't like that I got the sign wrong here. Well, so I do. Don't know why. So this is the path, and so omega 1 starts here. So that's the integral from here out to infinity, but the integral of omega 1 goes like this. So to get plus omega 2, we have to add this guy. So it should go around like this. And then out to minus infinity. Now, was that what I had to show? So, moves around the real points of the elliptic curve between minus n and unity, and z travels along the straight line. And as it travels along the straight line. Oh, that's another one from 0 to omega 2. So that's a red guy here. Oops. So we go from 0 to omega 2. Half omega 2, that's this point. So from omega 2 to 0, that was this integral. Yes, from here. So from 0 to, that's the opposite path going from here to this point, and then to add omega 2, yeah, that was the first half. This path will move, if we start at infinity and moving inwards, we'll move from 0 to half omega 2. Now to go to omega 2, we'll have to go around and then outwards again. wouldn't be. Now what does it move around the elliptic curve between minus and z travels along this, travels through the real of the elliptic curve, which are along all the real points. Well, I wouldn't say that really. I'd say we have to go around here and then outwards again along the same path. Oh yeah, the two ends at infinity are tied together. So this was lovely. So it was just an application of what all the work we had done in exercise 11 and 12. So I think I've understood finally these path integrals and can do them comfortably, though I'm still somewhat insecure, but I do get through it without too much crying out loud.